Hello, and welcome to this webcast and web recording from MuleSoft. Today we are going to discuss about healthcare transformations using MuleSoft and some of the healthcare APIs that MuleSoft has created in order to power some of these transformations. A high look at the agenda on what we are going to discuss today. We are going to discuss, of course, what the healthcare transformation vision looks like. We're going to follow that up with a healthcare integration template demo that MuleSoft has created in order to accelerate healthcare industry related integration. Following that, we are going to look at another demo, which is EMR integration using some of the FHIR resources that MuleSoft has created. Following that would be a demonstration of one of the EMR integration templates that MuleSoft has created using HL7. And of course, we are going to wrap the session up by creating or providing an advantage of using MuleSoft over any other integration solution, and the very fact that some of these integrations have been templatized, and what are the kind of advantages that you can derive out of this. We are excited to partner with Salesforce in the Health Cloud and build on a long track record of success in delivering value for customers with Salesforce. Our goal is in this partnership is to help accelerate Health Cloud customer time to value and help your customers better achieve their business outcomes, which will make them more likely to renew their subscription down the road and provide a platform for add-on sales. For those of you who may be new to working with MuleSoft, we have been working extensively with Salesforce for years in the healthcare space and have a number of shared successes in this space, which are some of which are listed in this slide. As many of you would already know, MuleSoft is implemented internally at Salesforce. So Salesforce is a MuleSoft customer. Salesforce is also an investor in MuleSoft and also a go-to-market partner for many of our joint customers. Today, I'm going to demonstrate some of the templates that MuleSoft has created in the healthcare space, and some of them have been used in powering the integration between EMRs and Salesforce Health Cloud. In this demo, we are going to showcase exactly how MuleSoft has been able to help customers get more value out of Salesforce, as well as how we'll be extending our product functionality to better support Health Cloud. To begin with, let us look at what is the business problem that we are dealing with in terms of healthcare and patient experience, to be particular. Patients and providers interact with each other via a variety of channels throughout the patient life cycle. These interactions are sometimes physical and sometimes they are digital and occur across a vast and ever-growing number of mechanisms. Providing a unified, consistent, and intuitive experience for customers requires these organizations to be agile with the capability of rapidly innovating in how they engage these customers during each phase of the customer life cycle. Now, the key points to take away from this are transforming the patient experience is fairly complex undertaking where there are a number of different permutations in terms of the channels of interaction and phases of the customer's life cycle. And of course, there is fragmentation in the terms of business processes and channels of interaction and engagement. That leads us to the next topic of the siloed system challenge. Traditionally, big stacks and vendor lock-ins have dominated the healthcare IT space. So while the demands to improve new patient experiences are mounting, the ability to deliver on the promises of digital engagement are fairly slow to cater to those requirements. The prominence of SaaS and cloud, along with the convergence of business models in healthcare, have proliferated this challenge. The patient information lives across systems that are internal to the healthcare provider, housed in the cloud, and within third-party business partners. In the past, a rip and replace approach has been the primary way to bring these new platforms into the healthcare provider ecosystem, which are forcing these health IT organizations to make more risky decisions and to have major cost implications. The fragmentation of these systems present an overwhelming challenge, which is being perpetuated by the ease of adoption of SaaS and cloud. Healthcare providers definitely need a new way to provide digital experiences that are collaborative, social, and mobile. So the key points to take away from this are there are various different systems which hold the patient information without really tying back together and talking to each other to provide that holistic 360-degree view of the patient. Systems are all over the place and in a variety of forms. And if you were to dive into each of these specific buckets of systems functionality, you would more likely find that there are typically more than one system. And again, break it up by geography and complexity increases. So the bigger you get, the more this is necessary. Now let us look at how can we possibly solve this challenge. One of the ways in which this challenge could be solved is from moving from a fragmented system approach to a much more composable and agile integration technology, which can bring all these applications together in virtually an application network that talk to each other seamlessly and that bring about that data fluidity so that the consuming applications which are consuming this data that is being unlocked from these traditional EMRs and other non-clinical systems are completely unaware of where the data is coming from or what format it is stored in. One such approach is an API-led approach, which is depicted in this slide. Here you can see that a lot of the clinical and non-clinical data is being exposed through various type of purpose-built APIs. And those APIs are composed together to bring about meaningful business functionality in some cases. In some cases, they are exposed directly as easy to consume sources of data. Now you have not just semantic and context, but also data elements available from these traditional complex EMRs, but in a very easily consumable format, which can be now be consumed by any application layer. And you can build in different types of intelligence and different types of application functionality into that application layer to provide meaningful functionality to the consumers and end users. So let us look at why a connectivity layer for healthcare transformation is really needed. Three key points to note over here. Of course, you want to reduce the lock-in with a single vendor and you want to lower switching cost when you are consolidating your EMRs in the backend or switching from one EMR version to another, or maybe switching from one data format version to another, like HL7 version 2 to version 3 could be an example. Of course, then the second point is you're unlocking the data in the EMR and making that data easily available to consuming applications. And the third major point over here is you're simplifying and streamlining the complex integration rules and formats like HL7, X12, etc., that are very difficult to consume and also to process, and making that transformation from that complex format to a very easy format. So these are the three key things that a transformation layer or a connectivity layer within the healthcare space could provide, and that could really be a game-changing strategy to actually bring about that rich set of data and functionality locked in the EMR out into consuming applications and build further intelligent and meaningful applications. First, let's talk about accelerating time to value. This is really key, particularly when selling to larger, more bureaucratic healthcare organizations, where there's a danger of implementation taking so long that the customers don't get a chance to realize the value of their investment before it's time to renew. This can obviously put renewals in a jeopardy. MuleSoft accelerates time to value for health cloud solutions by templatizing and productizing much of the work required to connect from Salesforce to Epic and other systems commonly found in healthcare organizations. This is something we have done at UCSF, which is a joint Salesforce and MuleSoft customer. UCSF uses Salesforce to create a single engagement layer across devices for a patient 360-degree view and as the foundation of their messaging app. MuleSoft connects Epic UCSF's EHR or Electronic Health Record System with Salesforce, providing medical information to providers and administrators in real time. We have productized a lot of the work that would traditionally be required to perform this type of integration, which leads to quicker time to value. Next, I would like to talk about how MuleSoft's flexibility can help Salesforce expand its presence into different parts of an organization. One of the really exciting things about MuleSoft is that it universally supports integration between all clinical and non-clinical systems, not just the most common ones. Previously, we talked about how accelerating time to value can help customers renew. Equally important is helping customers get more value out of Salesforce by leveraging it across multiple projects and business units. By supporting integration between clinical and non-clinical systems and data, MuleSoft facilitates Salesforce expansion from Health Cloud to non-clinical applications without requiring a separate integration solution, and therefore a separate engagement layer. For example, a hospital that uses MuleSoft to connect their EMR to Salesforce Health Cloud could just as easily use MuleSoft to connect data from non-clinical systems such as PeopleSoft, or which stores the employee information, or custom databases or data warehouses, example clinical trials information. Sounds great, but how does this actually look in practice? Let's walk you through how City of Hope, a cancer treatment focused hospital and joint MuleSoft and Salesforce customer, has leveraged MuleSoft to integrate data from clinical and non clinical systems into their Salesforce care coordination. This is the high level architecture of the integration that has been implemented at City of Hope. As you can see, City of Hope uses Allscripts as its EMR and Salesforce as its care coordination application. And in this mix, you will also see a variety of other applications like Enterprise Data Warehouse, Identity Management, and so forth. And MuleSoft acts as the glue that binds everything together to create that application network for seamless flow of information across systems. One of the important use cases that has been implemented is real-time integration between Allscript and Salesforce Care Coordination application, with patient information being interchanged. MuleSoft also serves as the orchestration layer for user provisioning across LDAP, and MuleSoft is also used to integrate analytics feeds from various applications into the enterprise data warehouse system at City of Hope. So as you can see, once a customer has brought in MuleSoft, it's much easier for Salesforce to cross-sell into different projects and business units because the integration piece is already there and the customer doesn't need to worry about purchasing and onboarding another integration solution. In this slide, you can see the partnership that Salesforce and MuleSoft has in the healthcare space. One such meaningful application targeted towards the care coordination space is Salesforce Health Cloud, which makes care coordination not just easy for the patient to follow and adhere to, but also for the caregiver to actually get that 360-degree view of the patient. Now, for Salesforce Health Cloud to effectively function, it relies heavily on the data that is stored in those clinical systems, especially the EMR. And this slide over here actually depicts how MuleSoft is being used to unlock that EMR data and get that real-time integration functioning between the EMR and Salesforce Health Cloud. Now, the picture depicted in this slide is the overall vision of this implementation of Health Cloud in a healthcare provider space. Some of these integrations are already live and templatized, which I'm going to talk about later in this presentation, but some is still work in progress, and we are going to list out what has been completed and available as a template. The key points to note in this integration are the out-of-the-box Health Cloud integration solution, which has already been tested with UCSF's Epic Sandbox. And this gives a very quick ramp up time in the initial installation of Health Cloud by quickly getting the basic EMR information integrated with between Health Cloud and the EMR. And these templates that are created by MuleSoft are supported by the MuleSoft's own product and services team with a deep down knowledge of healthcare and the healthcare industry as such. Now let us look at the MuleSoft templates for healthcare a bit more in detail. Of course, you have at the bottom the EMR from which the data is being exposed and the data being unlocked from the EMRs. And on the very top, you have the consuming applications that are interested in getting that EMR data. In the middle sits the integration logic, which has been templatized by MuleSoft and which are essentially divided into two categories: FHIR APIs and HL7 message handlers. FHIR APIs follow the HL7's FHIR standards or Fast Healthcare Interoperability Resource standards, which are essentially JSON-based representations of the EMR data and created as and deployed as FHIR resources or endpoints. The templates themselves rely on some of the native APIs that the EMR might expose and uses them to and transforms them to FHIR related standards and of course JSON format. The FHIR APIs are implemented in tiers so that they can be easily composed based on the need of the business process or the data that the application needs. So the FHIR resources actually rely on the native API that the EMR exposes, uses that API to get that data out of the EMR, converts that into FHIR resources, and then makes them available to be composed as part of business processes or as part of Experience API, which could be further simplified based on the need of the calling application. We will see how this works in a demonstration later. The HL7 message handlers, on the other hand, subscribe to the HL7 message feed that the EMR publishes. Once that message is received, the HL7 templates transform that into XML, identify the type of message, and can easily do content-based routing or other types of routing to convert those HL7-based messages into FHIR resources. And once they are converted into FHIR resources, which are essentially in JSON format, they can be easily published to other applications or pushed as notifications to other applications. We will also see this in an example in this particular presentation. A key point to note here is these templates are implemented for specific applications and EMR, but at the same time, they are agnostic of the consuming application and the EMR and could be easily extended to any EMR scenario and to any consuming application scenario with some minor changes to their mappings, but essentially provides a starting point for any and every of your EMR related integration. As a reference implementation for these types of templates, we have chosen the application layer as Health Cloud and the EMR as Epic. So essentially what these templates have been implemented as a reference implementation is integrating Epic with Salesforce Health Cloud. The FHIR resources depicted on the process API layer, FHIR resources like patient, allergy intolerance, medication, etc., use Epic's interconnect services to which essentially use the SOAP API of Epic to get the data out of Epic and convert it into FHIR resources. Once they are converted into the individual FHIR resources, there is an experience API that has been created specifically for Health Cloud, which accepts requests in a batch or a single patient format, aggregates all the FHIR resources that are required for populating the Health Cloud instance, and populates the Health Cloud instance with that data from the Epic instance. For the HL7 messages, the HL7 message handler subscribes to messages from the Epic Bridges interfaces, converts them into individual FHIR resources based on the type of event and the type of HL7 message. And once they are converted into FHIR messages, they are then updated into the Health Cloud based on the type of entity that the message is for. We will see all this in an example later in this presentation. Now let us look at a quick demonstration of some of these templates. We will first begin with the FHIR resources and the FHIR APIs. For that, I will navigate to mulesoft.com/exchange, which will bring up the Anypoint Exchange page. Anypoint Exchange is a one-stop shop for all connectors, templates, examples that MuleSoft provides. And since these FHIR templates are public, you should be able to easily locate them here by filtering on FHIR. You will then notice a number of FHIR-related APIs. We are going to take a sample one just to demonstrate what it shows. Let's take the medication FHIR API. You can look at the details. There's a little explanation for what it actually does. And further open it up in the API portal to actually look at the definition of the API. I'm going to actually try this API to see what are the kind of parameters it takes as inputs and what does the output look like. So I'm going to enter a patient ID and the ID type is MRN. You can notice that the endpoint URI got populated based on the details that I entered. Since this supports the get action, you click on get. This is going to get me the FHIR JSON response for a medication for a particular patient. If you look at it, there are certain codes that it returns and of course the text of the medication information. This is a much easily consumable information, which is in JSON format. And now I can use this particular API to actually get medication information for any patient, which is locked in this Epic instance. Next, I'm going to demonstrate the HL7 message handler. For this, I've opened the HL7 message handler template in the Anypoint Studio. Anypoint Studio is an IDE for designing any integration process, provides a very easy to use and intuitive drag and drop interface wherein you can drag the components that you want to work on and drop them in the canvas and link them together to create the integration logic. For the HL7 event handler, I'm going to use a variety of HL7 related components that MuleSoft's Anypoint platform provides. To highlight a few of them, I would be using the HL7 MLLP, HL7 acknowledgement, and HL7 transformation. This template actually listens for an HL7 message on a particular port, converts that into an XML, and then decides based on the type of message and the type of event that has been received, decides on the further course of action by pushing them into sub-processes. For example, if there is an ADT A01 message coming, it passes it to this ADT A01 sub-process, and this sub-process will actually transform this ADT A01 HL7 message into a FHIR resource using data weave, which is the transformation engine provided out of the box in MuleSoft and is very well capable of handling HL7 messages and also FHIR standards. Once it's converted into FHIR resource, it actually updates the required entities in the Salesforce Health Cloud to ensure that the updates that happened in the EMR are kept in sync with those in the Health Cloud in a very real-time integration pattern. For this demonstration, I'm going to start this process in debug mode. Put a breakpoint on one of the components so that the message stops and we can step through and see what's going on. I'm also going to use Happy Test Panel for posting the HL7 message so that it's posted in the MLLP transport protocol. For that, I've already made a connection to this particular port that I'm running my HL7 integration process on. I'm going to just start that connection. And here I have the test message, which I'm going to send to this particular connection. Click on send. This message is being received by the HL7 MLLP connector. And it's now, since I've put a breakpoint on the log step, it's waiting to now move for me to take any action. If you notice, this is the HL7 message that has been received. And as I step through this process, you will notice how the transformation is done. This is an asynchronous process, so it provides the acknowledgement so that other messages can be received, and the calling application does not wait for the entire process to complete. With the HL7 transformer step, that HL7 message now is converted into an XML message. It has been identified as an ADT A01 message. This process will now convert it into a FHIR message. And the logger step should log that FHIR message as a log. So now you can see that the HL7 message got converted into this easy to consume JSON message for a particular patient. And this message can now be updated on to any consuming application that is interested in receiving this message. In this case, it is being updated in the Salesforce Health Cloud instance. So this demonstrates how a template for the HL7 message handler is being used to handle different types of HL7 messages from the Epic Bridges interface. And those HL7 messages are being used to update the related entities in the Salesforce Health Cloud instance. This slide depicts the list of templates that have been made public and live in MuleSoft Anypoint Exchange. And you can find them easily by visiting mulesoft.com/exchange and filtering on FHIR. This explains the high-level reference architecture when you put everything together, especially the Epic EMR, the Salesforce Health Cloud, and all the FHIR API templates and HL7 templates, and how they interact with each other and make that real-time integration possible between Salesforce Health Cloud and Epic. And all this sits on the secure MuleSoft environment. The APIs support a variety of policies that can be applied on it, especially security policies. And of course, Anypoint Platform can be run either on-prem or on the cloud or in a very hybrid manner, and is an extremely scalable environment and for integration, and is an extremely scalable environment which can scale to any kind of transaction needs within the healthcare space. We saw how we are using the connectivity to EMR or the native APIs of the EMR as system APIs. MuleSoft then converts them into a canonical, which is the FHIR standard, and those become the process APIs. And then those process APIs are composed together to create the easy to consume experience API. And the one that has been created is for Salesforce Health Cloud. For the HL7 messages are published by the Epic Bridges. Those messages are received by the HL7 message or the event handler template, which is created and deployed at MuleSoft. And then those HL7 messages are converted into FHIR resources or JSON format and updated to their respective entities within the Health Cloud using Health Cloud System APIs. So this creates an end-to-end real-time integration between Epic and Salesforce Health Cloud. All this is running on the MuleSoft's Anypoint platform, which has the Mule runtime engine at the heart of it, running on some platform services. And of course, we are using the Anypoint connectors and templatize this and design this using Anypoint Design Portal. Managing API management is on top of this is provided by the API Management Center, and all this is templatized and exposed within Anypoint Exchange. Now let us look at an end-to-end demonstration wherein we will get EMR data from the EMR. Now let us look at an end-to-end demonstration where we will get EMR data from the EMR and update that information in Salesforce Health Cloud. So essentially, we will be looking at the interaction of all these APIs that are depicted in this slide. For this demonstration, I have logged into Salesforce Health Cloud instance and navigating to the candidate patient list. Now, the candidate patient is a patient in Health Cloud with minimal medical information. Critical information like MRN, date of birth, etc. are recorded through a predefined process and uploaded into Health Cloud. Our example patient that we are going to use for this particular demonstration is Andy Rhodes. As you can see, Andy Rhodes does not have any patient record, but just has a candidate patient record with minimal information, especially the MRN. We are now going to get the EMR details of Andy Rhodes. Let's verify first that Andy Rhodes is not yet a patient with all the information. For that, we will navigate to the all patient list view and ensure that Andy Rhodes does not exist as a patient yet. Navigate back to the candidate patient record. Click on Andy Rhodes. And now I can see the candidate patient details for Andy Rhodes. For the purposes of this demonstration and to show how we can invoke a process from candidate patient and convert that candidate patient into a regular patient by getting all the patient data from the EMR, we have created a button over here called Pull EHR. When I click on Pull EHR, this invokes the MuleSoft's Experience API for EMR, which in turn invokes the FHIR APIs and gets all the data from the EMR. When I click on this information, when I click on this button, I get a list of entities that have been uploaded to the Salesforce Health Cloud instance, which shows me that the process for fetching the EMR data from the EMR has been successful. Now I'm going to go back to the list of all patients. And I should be able to see Andy Rhodes now created as a patient. Remember earlier that Andy Rhodes was not available as a patient, but since I clicked this button, that invoked the API, which fetched all the information and updated the related EMR details and created Andy Rhodes as a patient. If I click on Andy Rhodes patient record, I should be able to see patient card of Andy Rhodes, which provides critical information about the patient. It provides things like date of birth, gender, address, allergies, conditions, etc. I can also verify that the last update of the EMR happened now. Date should show the current date. And on the care plan and timeline view, I can see all the data that came back from the EMR. This was a medication that came back from the EMR. There were 2 conditions that were reported, and there are 2 observations that are reported for Andy Rhodes. And if you hover above the list, you can actually see details. I can expand this timeline view to show more details from previous timelines. And I can also see there is some allergy information about Andy Rhodes that has come back from the EMR. So this particular demonstration uses the healthcare templates created by MuleSoft with a reference implementation using Salesforce Health Cloud and powering that through the click of a button. Let us now look at the end-to-end demonstration for HL7 messages. This demonstration will help receive the HL7 message being generated, convert that using our HL7 event handler template into a FHIR message, and that FHIR message will be updated into the Salesforce Health Cloud instance. For this demonstration, we will be using a mock EMR, which will act as the Epic Bridges interfaces and create an HL7 message. For that, I've logged into this mock EMR system. And as you can see, this mock EMR system has Andy Rhodes as a patient with some details on Andy Rhodes' address and phone number, which currently matches that with the Health Cloud instance. I'm going to mimic an address change, updating the address, saving the address record as it would get saved in the EMR, and clicking on Update Patient Address. This actually generates an HL7 message of type ADTA08 and publishes that to the HL7 event handler template, which is deployed on the MuleSoft's Anypoint platform. It also receives an HL7 acknowledgement back that the MuleSoft process has received the message and has processed it. Now let us navigate back to our Health Cloud instance and navigate back to Andy Rhodes' patient record to see if the address was indeed updated here. We now see that the 77 Geary Street address has been changed to 300 California Street based on what was updated in our mock EMR instance. So this proves and shows a typical scenario wherein an update happening in an EMR would be published out as an HL7 message. That HL7 message would be handled by the MuleSoft's HL7 event handler template and published into Health Cloud, and the appropriate entities in Health Cloud would be updated with that information. In this case, the patient information was updated at the appropriate location so that it shows up in the patient card and all the other related information. So this demonstration shows the implementation of the HL7 event handler interface in an end-to-end scenario. Now let us look at some of the advantages that you get by using the MuleSoft's connectivity platform. Of course, you get this entire integration is templatized, scalable, and extendable, and not tightly coupled as might be the case in a point-to-point scenario. You're dealing with easy to consume JSON format messages, which are in FHIR standards, as opposed to pipe delimited HL7 messages. And of course, the MuleSoft templates are implemented using industry canonicals like FHIR and HL7 rather than custom data formats. Here are some of the key MuleSoft differentiators vis-a-vis other ESB solutions. And here are some customers that are using MuleSoft in the healthcare space. I would like to conclude this recording with a note of thanks. Thank you for joining us during this demo series. I hope this was useful in educating you all on how MuleSoft can support the integration needs of Salesforce Health Cloud accounts. I want to wrap up by speaking to the broad experience MuleSoft has in the healthcare space and in working with Salesforce. MuleSoft has delivered many in-production solutions with Salesforce in the healthcare space, and we have also partnered with leading GSIs when needed to ensure customers are successful. This provides assurance that customers will realize their intended value from a Salesforce MuleSoft solution. We are continuing to further develop our product and our partner relationships to be able to support Salesforce in the healthcare space even better than before, particularly as HLS grows in importance for Salesforce. We feel we are just getting started and look forward to being a partner in Salesforce's success in the healthcare space. Again, my name is Bikram Sen, and thanks for viewing. Please feel free to reach out to me or any of my colleagues here at MuleSoft directly if you have any questions. Thank you.